Hello, ALAS friends. Thank you so much. I want to start with a question. How many of you changed your cage change protocols based on the pandemic or based on labor shortages that you were or are still experiencing? So if there was a cage that can go out to 3 weeks between cage changes, maybe that could be beneficial to you in your operation. So today I'm going to talk about the Lenderking Hygieia IVC. Hygieia is named for the goddess of hygiene. That's where we get that word. And Hygieia acts very differently from other IVCs. We use airflow a little bit differently, and we place the bedding here on a perforated false bottom and bring the airflow in at the bottom of the cage. Now the airflow has to percolate up through all layers of the bedding, through the bottom, middle, and top layers of the bedding to get out the top of the cage here. This essentially turns the entire footprint of our cage into an airflow nozzle. You're gonna have this pocket of air down here. Air is gonna come in here and balance out. And then this does a couple cool things for our design and our performance. In a traditional IVC, you're gonna push a lot of air through each cage. 60 air changes per hour is very common across the industry. We can turn that down by half in Hygieia. So we use airflow very efficiently to keep the bedding dry, and so we can turn that down to just 30 air changes per hour. I've seen this cage run as low as 15 air changes per hour. Even with that lower, slower airflow, we can still go out to 21 days between cage changes. Because our airflow port is at the bottom of the cage, that means this cage will never flood, never, ever, ever. Because I talked about this a little bit already, but our airflow acts kind of like putting a diffuser on the end of your hair dryer. Air is going to come into that bottom plenum, balance out, and now percolate up through all layers of the bedding across the entire floor of the cage. So now the entire footprint of the cage, 82 square inches, is our airflow nozzle. Whereas in our competitors' cages, they're pushing a lot of air through a small nozzle in the back wall of the cage. This acts a lot like pinching the end of your garden hose, which is going to make that stream come out faster and act like a jet stream ripping through that little cage. When you control the wetness of your bedding, you can control ammonia in your cages, so dry cages equal low or no ammonia in your cages. Just a quick note about rack design. A lot of folks will use what we call a dead-end plenum design, so you're going to have less airflow out here. We use a double-ended plenum design in our rack, which helps us balance our cages left to right, top to bottom. Again, this is our CFD of this system. If your manufacturer doesn't present this to you, you have to ask why. They all have to do it to sell their cages in Europe. So a lot of people give me pushback when I say you can run out to 14 or 21 days in this caging system. They say, oh, well, the guide says you should go out to 14 days, or you should change every 14 days. So that is a should, not a must, and they actually call out this exact case where using perforated cage bottoms can extend your cage change interval, and they do say there's no minimum frequency of bedding changes, and the choice is a matter of professional judgment. So the title of my talk was How Can Hygieia Do More Than Save You Money? So let's talk about how it can save you money in all of these categories: labor efficiency, animal lives, and breeding production, water usage across washing your equipment, energy usage across washing your equipment and running your blowers, consumables like bedding, enrichment, and food all see savings when you extend cage change, the lifespan of your equipment. When you're not washing as often, your cages don't get cloudy as often, and you don't have to change them out. You don't have to buy new cages because you can't see through your cages. And every time you change a cage, that adds to your waste disposal costs. So across all of these categories, according to our cost models, the system pays for itself in 3 years or less. Nobody uses an IVC for just 3 years. You can put those savings after the first 3 years into your program however you see fit. So Hygieia is good for more than just your budgets. Let's talk about a couple different categories. So we always think about the different users of a cage. You have the facility and the managers that buy the cage and manage the system. You have mice that live inside of the cage, and then you have technicians that change it every single day, or technicians that change your cages. So let's think about each of these categories. So from the mouse perspective, low ammonia is great. This is a study that we did with the NIH. This is 5 mice in the cage. This is an expensive PID sensor and performance paper bedding, but this is 18 out of 20 cages registering 0 ppm ammonia on day 21. I have posters on this work, both on the sensor perspective. This was the first time we used a wireless ammonia sensor, and we also were drilling down into what types of beddings work best in this caging system, so I'm happy to share any of this work with you if you're interested. I talked about how Hygieia will never flood, so you're never going to come into your room and see a cage full of water with a mouse swimming, or worse. Never going to happen. There's a hole in the bottom of this cage, so your water is going to run out into the rack before it fills up the cage. You have to watch the bottom row of cages, but you do have more than 24 hours of space in that bottom plenum. And then if it does run out into the cage, you just open each plenum at the end of the rack, and the water will run out there. It'll be fine. Cage change is stressful to mice, so anytime you can extend that, that's better. They have nests that they have to reestablish in a fresh cage, pheromone cues, which help them establish their social dominance and hierarchy there. And every time you pick up a mouse, it is flooded with cortisol, and cortisol has been shown to affect things like the endocrine system and other factors in your research. So stress can add noise to your research. So if you can reduce that with reduced handling, that's going to be better for everybody. We did a study with AstraZeneca trying to get to once-a-week cage changes in this system. That proved to be a little ambitious, but we were able to keep a Lenderking cage with 5 mice in the cage for 1 week. The humidity is what killed us. The humidity was a little bit high than what they would like to see. So I believe if you went down to 4 mice in a cage, you could absolutely do once-a-week cage changes, even in a challenging model like diabetes. From the technician perspective, NIOSH and OSHA give you limits for how much ammonia a human is allowed to be exposed to over the course of an 8-hour workday. The problem with this is your mice don't get to go home at the end of the workday. So controlling ammonia in your rodent cages is good for the exposure of ammonia to your technicians. Additionally, when we were designing this system, we worked with an allergy lab out of Hopkins to look at MUSM1 protein, which is the major allergen in mouse urine. So we chose a filter material that's going to capture the most amount of that allergen, reducing exposure to your technicians. So again, if you can control the wetness in your cages, you do not have to spot change as much. So your technicians will have more control over their day, and they won't get caught up with spot changing a lot of cages in each room. From a facility perspective, you're going to get better research out of these cages due to the reduced stress from handling, reduced ammonia, cleaner, drier, easier to breathe air with less VOCs. Like ammonia in there is good for your animals, good for your research. You're never going to have to replace animals or cages due to a flooding incident, and we do have data to back up increased breeding production over our competitors in this system. So this is a study that we did with Cornell University. This is looking at comparable cages with the same amount of pups in it. Look at the ammonia scale here in the Lenderking cage. We can keep the ammonia levels under this industry standard of 50 parts per million at cage change. In the Allentown system, we saw high ammonia by day 14. You can't, my video is covering the scale here, but this is day 14 where you would normally change a cage. So here you see cage changes. This is, by the way, this is data from those wireless ammonia sensors, which I'm happy to talk about if anybody is interested in learning more about those. But you can see with that type of biomass in these cages, the ammonia levels get pretty high and warrants a cage change during the weaning period. So we did get statistically significant 2 more mice per litter to the weaning age as compared to our competitors. And again, we presented some posters on this work at ALAS, which I'm happy to share with anyone if you're interested. Labor savings. So when your techs are not spot changing all the time, they have more flexibility in their day. You can cross-train them in different departments and maybe change the ratio of staff to cages so you can increase your capacity without adding more people. From an environmental perspective, this system hits a lot of categories: water and power savings, waste disposal. If you're going for LEED certifications in your buildings, this can help hit a couple of different categories. And I personally have a couple of feelings about disposable caging. I was an environmental activist for a year of my career before joining Lab Animal. So if anyone wants to talk about this, I gave a talk at Llama a couple of years ago, drilling into the environmental considerations in the vivarium, and I'm happy to talk to anybody about that work as well. This is real data from a facility in California that made extended cage change rules. So they said if we have one mouse in a cage, we can go out to 4 weeks between cage changes. If we have 2 or 3, we can go to 3 weeks. And they saw about $400,000 worth of savings by implementing those rules. This is in 2018 money, and again, a system of 20,000 cages. They also saw a lot of savings in water, power, and waste as well. In conclusion, this system is great for mice, for technicians, for your research, for your facility, for your environmental considerations, and your budget. If anyone is interested in measuring ammonia in your own cages, I've been involved with 5 different ammonia studies at this point, and I've overcome a bunch of hurdles in doing that work. I have a little webinar put together where I teach facilities how to measure ammonia in your own cages. I have opinions about sensor ports, how to get a sensor into your cage, and what types of sensors at what different price points are worth looking at. So I'm happy to share any of that knowledge with anybody who wants to measure ammonia in your own cages. So thank you very much for your time and attention. Thank you so much for everything you do for all of the animals in your care. And at this point, I will take any questions. Thank you so much.